And then Christine, if you want to share your screen real quick, or I
Oh,
can
yeah, sure. I'm going to go ahead and do that. Apologies, that's a little bit tiny because I'm using my secondary monitor and it makes things weird.
All right. Hello, everyone, and welcome to the lightning talk portion. We have, if I can count, we have 5 lightning talks scheduled. So the way we're going to do this is we are going to go through each lightning talk. It has about 10 minutes, so we'll do each lightning talk. After I've introduced them, they'll get a chance to do their lightning talk. And then at the very end, we should have it some time for questions. So please, as usual, put your questions in Slack, and we'll review them after all the lightning talks have had a chance to be done. So I'm going to start with Finding Our Lodestone, Evaluating Linked Open Data for Qualitative Research by Kate Topham, who's a digital humanities archivist at Michigan State University. And let me go ahead and share screen and hope that I can do that right. And then Christine will also be dropping links in chat because Kate was kind enough to send us several links ahead of time. And they were also on Sketch, so we should be fine there. So I'm just going to go ahead and share the screen now. Everyone should see something that says Finding Our Lodestone. Is there any trouble with the audio, please let me know. So I'm going to go ahead and hit play.
Hi, everyone. My name is Kate Topham, and I'm the Digital Humanities Archivist at Michigan State University. And today I'm going to tell you about an ongoing linked open data project that I started as a leading fellow last year. So as part of my fellowship, I was partnered with the Schoenberg Database of Manuscripts out of the University of Pennsylvania. The Schoenberg Database of Manuscripts contains observations of pre-modern manuscripts. So that means we have information not only about the manuscripts themselves, but about provenance agents, so the people who collected these manuscripts, as well as the firms that bought and sold and auctioned them off. So we have provenance information, and this is all derived from catalogs and inventories and crowdsourced data from a dedicated network of volunteers. And it's all available as a Sparkle endpoint. So for my piece of this project, I decided to take classical Latin manuscripts as kind of a case study to see what we could learn from this data. You know, is there any new knowledge to be derived from this vast and this like rich resource of data, to see kind of, all right, maybe there are some networks of provenance in this data. Maybe the same folks are trading manuscripts. Maybe we can track classical reception by how popular different authors are over time. So after a long period of learning Sparkle, querying the data, cleaning the data, wrangling the data, I created some visualizations to try and address these questions. So first, I looked into what I'm calling circulation. So this is kind of a measure of an author's popularity. So for the 20 most common authors of classical Latin manuscripts, I noted every time that a manuscript by each of these authors was bought/sold, and if they were noted in an inventory. So you get a point every time your manuscript is owned by somebody, and you get a point every time it's bought or sold. Those are separate provenance records. And so I tallied all of that up, and I grouped the authors loosely by genre, very kind of imperfect. And looking at this, you can see that philosophy and poetry are by far the most popular in terms of genre. Philosophy is slightly bigger, but in poetry, there are a lot more authors represented within the genre. And in philosophy, it's pretty much, well, it's mostly Cicero, which if you know anything about classical reception, it's not surprising. Cicero is an extremely influential author. He's this yellow bar here. And the other philosophy author is Seneca. But poetry is a lot more diverse. So kind of something to be expected, Seneca is popular and Cicero is extremely popular. So then I turned to focus on the provenance agents and into the transfer of manuscripts. So I created this network in which all of the nodes here are entities, are provenance agents, people buying, selling manuscripts, sometimes institutions, museums, universities, monasteries. And there's a lot more to look into here. I'm not super experienced with network analysis, but we can see there's this thick line between these two nodes that sticks out by a lot. That thick line is showing that there's a lot of manuscripts transferred between these two nodes. And these two nodes are Bernard Quaritch, which is a very prominent manuscript dealing firm, and Sir Thomas Phillips, who's also an equally famous manuscript collector. So we're seeing sort of things we expect to see here. Yeah, we've got a big connection between two very important players in the manuscript scene. And finally, I created a visualization of the top 5 authors. I created a map and timeline visualization that shows the location of agents who collected these manuscripts, along with the when these agents existed. So for people, that means the dot appears for between their birth and death date, and it is sized by the number of manuscripts they collected and then colored based on the author. So many of these folks collected manuscripts by more than one author, so you'll see kind of rings. And as we go through, there's a few entities that have disputed or don't have dates listed. So that's why we get dots in New York and America as early as 400. We do have manuscripts that we do have agents that go that far back, but not in America. But other than that, you can see there's hot spots in the UK, in France, in Italy, and then towards the end of this data set, we start getting California, New York, Midwest in the United States. So kind of things that we would expect to see, places where we know there's a lot of interest in these authors. So as I was doing these visualizations, I was kind of feeling a little bit frustrated with the difficulty of this data. There's so much missing. One of the reasons I ended up mapping the agents instead of the manuscripts and doing the dates by the existence of the agent rather than when they bought or acquired the manuscript was because we just don't have that information. We don't know when. For 99.9% of the cases, we do not know when those manuscripts changed hands exactly. There's also some complexity and ambiguities in this data. There are many families represented here who also had firms, and it's unclear which member of the family acquired or sold a certain manuscript, or if it was the firm, for example. The data is also very much skewed towards institutions and people with power and wealth, because those institutions and people are much more likely to have records of their collections because they're larger and it's more notable when their collections are being auctioned off, for example. And all of these drawbacks started making me feel kind of like I wasn't really doing anything, that my research didn't amount to anything. Oh yeah, Cicero's popular. Yeah, Thomas Phillips bought and sold a lot of manuscripts. Who's surprised? And in my kind of existential dread, I went back to my map and timeline visualization and started looking at kind of what, looking for some smaller details. And I noticed this yellow dot up here. And it stuck out to me because yellow is Juvenal, who's he's kind of the smallest of the big 5 represented here. And people don't tend to collect very much of him. It's usually one out of a larger collection, 1 or 2. And so I investigated this little dot and found that it corresponded to Gustav Ritter von Amich, who's an entomologist from Budapest. And he He collected over 20 manuscripts of Juvenal. He has a couple by Seneca as well. And I kind of went down on this rabbit hole doing research on him and looking into his works and what he's done, and filled out some of his Wikidata item. And when I came up for air after this rabbit hole, I realized that I had been thinking about my project all wrong. I had been hoping that these visualizations would answer my questions, but actually the visualizations should be the questions. We're not trying to like look for the forest instead of the trees. We want to use the forest to find these interesting trees and pull out those little details. And this is precisely why humanists are perfect for linked open data. This approach is particularly good for humanities people, because we're trained to look for those details and those nuances in a lot of noise, in a lot of messy data, and working with partial sources, trying to reconstruct a narrative. And so linked data research, even with all of these caveats of the messy data and the missing data, linked open data research can be, it should be part of a process of stitching together these clues to form our larger picture, to dig through kind of all of that noise to find the interesting thread. So I will leave you with that. There's still plenty to be explored in with this data set, and I'm happy to talk manuscripts with you, talk linked data and Wikidata with you. Here's all my links and a link to my slides, and I'm really looking forward to sharing more with you once I've done a little bit more with this data. Thanks so much.
All right. Like we said, that was great. Thank you, Kate. And then Kate will be here for questions at the end. What we're going to do now is hand it off to our second presenter. Once we're done with all the lightning talks, then we're going to have some time for questions. So next up, we have Sinopia resource templates implementing official RDA with our presenter, Benjamin Reisenberg, who's a metadata librarian at cataloging in the Cataloging and Metadata Services Department at UW Libraries. So Benjamin, you should be able to share your screen and start.
Thank you, Huda, and thank you everyone for being here. I'm glad to have the opportunity to talk about this project. So to get right into it, we're using the RDA RDF ontology. It's been published since 2014, and as of creating this slide, it is on upwards of version 5. It has some nice features. You can see a couple of screenshots of the web interface where you will wind up if you dereference an IRI for a class or a property or a term in a browser. You can see that it is internationalized into a number of languages that you can see in the lower screenshot there. So the goal of this project, creating Sinopia resource templates, implementing the ontology, and eventually using those templates, is one, to develop best practices for implementing RDA RDF, to answer the many questions that arise in using this large and complex ontology to create data. And I'll very lightly touch on those later. And then, of course, second, to create a data set, which we hope will be of interest to the community as libraries continue to move out of MARC and into linked data and evaluate things like data models and how we want to structure our data and create our data. I know it'll be of interest to us. This project is one of many that have taken place, are taking place at the University of Washington, that are to do with the RDA RDF ontology. It's one of 2 active projects at this time. The other project is a mapping from the MARC 21 bibliographic standard to RDA RDF, and I think Laura Ackerman will be giving a presentation to do with that project sometime later in RDF. I'm sorry, sometime later at LD4. But really, the project is kind of continuing to test what I would call our hypothesis, the hypothesis of of the sort of working group that we have that's been involved with these projects at the University of Washington, which is if we want to create RDA data, if we want to create data using RDA as a descriptive standard, then as we move into linked data, in fact, it seems to make sense that the RDA ontology is a very suitable tool, maybe the most suitable tool in order to do this. Thinking about it from a different perspective, catalogers have undergone a great deal of training in interpreting and using RDA elements, relationship elements, attribute elements, training in the conceptual entities that are part of the RDA model, all for the purpose of creating this very detailed, very granular, high quality library data. And if, as I say, we want to continue to create this kind of high quality data, then we have this hypothesis, which is why not use the linked data ontology, which was actually built around that model. So that's sort of the background for this history of projects. Some other characteristics that we think are important are, as I say, it's a highly expressive model. The fact that it is explicitly aligned with the IFLA library reference model. And I meant to make the distinction before. I think a couple of my slides have made a point of introducing or using the term official RDA to differentiate from original RDA and make it clear that we're using RDA that following what was called the 3R project, the toolkit restructure, the RDA toolkit restructure and redesign project has been brought into alignment with the IFLA library reference model. And then finally, I want to mention the fact that properties in the RDA, RDF ontology are mapped to external schemas and standards, and that this facilitates us sharing data with other users, other consumers of the data who may not want or need the same degree of detail or granularity. The current status of this project is that we have a number of Sinopia resource templates, which were created for describing print monographs. These were authored by Zhuo Pan, who was until recently a graduate student at the University of Washington iSchool. And we are currently testing these templates in a relatively small group. They are loaded and they're being tested in the Sinopia stage environment. We want to do a first round of testing before loading these to the primary Sinopia environment, Sinopia production. So as updates are being made, and in fact, we've only met once with the testing group, but that one meeting has already resulted in getting feedback from catalogers and actually making changes in the templates. So as this happens, we will continue to load updated templates to the Sinopia stage environment, but they are also available outside of Sinopia as HTML documents that can be viewed alongside with some additional resources at the URL that you see here. And the PDF I loaded to my presentation page includes all the links that you see in my slides. So that's where we are right now with the project. As I mentioned, one of the goals is to identify the best practices in implementing this ontology, and we're finding that there are many questions, or you could say challenges. In this lightning talk, I won't go into detail, but if you're interested, you could certainly follow up with me in Slack or otherwise. And I did present alongside Zhuo Pan, the graduate of the iSchool here that I mentioned earlier, at the PCC Sinopia Cataloging Affinity Group back in May. And he was able to go into detail about a lot of these challenges, and those slides and presentation recording are available. But a couple of things that might be interesting to mention. This is interesting to me because it's a situation where a characteristic of the data model and a characteristic of the data entry platform are interacting. Well-formed RDA, RDF does not include blank nodes. this is a characteristic of the data model. This is something we've identified as a best practice. The upshot of this is that we can't use some Sinopia functionality which creates blank nodes. So there's a very nice feature called a nested resource template in Sinopia, which allows you to describe two resources in the same data entry form without switching tabs. But this creates a blank node. This identifies that second or nested resource with a blank node. So the upshot is that we're finding we have to manage a larger number of tabs as we do our work in the Sinopia platform. Another ongoing discussion and area of question for us is when we can use values from external controlled vocabularies and ontologies. Mileage seems to vary on this. Thinking about a property which expects a value of RDA person, we have a great deal of confidence that we could provide an IRI for a Wikidata item that's modeled as an instance of human. It doesn't seem that this would create any conflicts down the road with people who want to use our data. With the semantics of that property, which expects something that RDA thinks of as a person, and providing a resource that Wikidata has defined as a person. But when we think about creating, for example, a work-to-work relationship, obviously this is a really important question. We're talking about linked data, so we want to link and connect data from different sources. But the idea of connecting an RDA work with a BIB framework, which includes information that's associated with both an RDA work and an RDA expression, and the fact that those two entities are disjoint in the RDA model seems like something we can't do with confidence, something that could cause problems for future data use. And so, again, an upshot here is that as we build our data set, and we want to, of course, create these work-to-work or WEMI, they're called sometimes resource entity to resource entity relationships. We're going to have to at least minimally describe all of the resources involved in those relationships. Again, these are just a couple of the questions that we're looking at. I haven't even mentioned things like including provenance data, or creating relationships to subjects, or a number of the things, the other questions that are coming up as we test these templates. But I'm very excited to move forward with testing with our small group, and hope to report out on our work again in the future and make these templates available in Sinopia production. Thanks again.
All right, thank you, Benjamin. So up next we have Scraping Wikipedia to Make Links with Rebecca Barabas, a librarian in residence at the Library of Congress. Rebecca, feel free to go ahead, share your screen, and if there's anything else you wanted to add to your intro, please go ahead.
Hi. Thank you. It's great to be presenting today. So just to start out, first of all, just works making me say this. This project is based on this presentation is based on a personal project and is not related to my work at the Library of Congress. This is something that I did during my free time. Also, I am an intermediate coder. So those of you with more coding knowledge might look at what I've been doing and think that's obvious, or she should have done it this way. Those of you with less coding knowledge, I am optimistic that this presentation should still be accessible. The code itself might just be a little bit more confusing. So the problem that I started out to address arose when I was creating Wikipedia pages. I regularly reference the Women in Red lists, and found that sometimes I would start making a page and realize, actually, that page already exists. The problem was that the list was created by scraping Wikidata, and it just somehow didn't align with the page that already existed. In general, because there are multiple Wikidata items for one person. So I created code to help address this issue. I am pasting a GitHub repository in the chat for those of you who would like to look at it. So first, what do I put in? I decided I wanted to use the page ID. Don't need to worry about spaces as much, or URLs, or things that are a little more fluid. And in the coding, it looks at the API, which is, for those of you who don't know, an API is a software that helps software speak to other softwares. It retrieves the data. So then it makes a list with the relevant data for this particular project. I decided that was the name, the Wikidata code, and links. And then it searches Wikipedia for the person and returns results. It prints to a table. I circled this. I used Google Colab to make it. You need to press a little button to make the table look pretty. So that's what I circled. And then it requires a manual search. For this example, I used the rugby league. It's a shorter page, so it was fairly easy to navigate. And as you can see here, we have Georgia Hale, who it was on the Women in Red list, but there is this other Georgia Hale rugby league link. So it was fairly obvious this is probably the same person. And then it requires a manual merge. So some of the issues that I came across, one, in the example I just gave with Georgia Hale, it was pretty easy to say, yeah, this is the same person. I could be pretty sure there is one Georgia Hale who plays rugby in the rugby league. But with some people, if there's multiple dates of birth that exist for the person, because they were born a long time ago or because less information is known, it could be a little bit more difficult. Also, Women in Red is a pretty unique project. There's not a lot of lists of red links outside of that, so there's not a ton of reusability. Finally, like I said, the rugby league I chose to use for this presentation because it's pretty short. There's some lists that are really, really long, and those take longer to process because they're longer lists, and they take longer to manually review. And, you know, time is precious. So I thought, well, what if I do it the opposite way? So I looked at the Wikipedia page for Judy Chicago's feminist artwork, The Dinner Party. There is a supplemental work called The Heritage Floor that has 998 women featured on it. So I thought, how can I see which Wikidata pages for these women has the dinner party mentioned? So here I did use the URL. It was I had a trickier time using the page code. Again, I'm an intermediate coder. And then it looked through, rather than looking for Wikipedia pages, it looked at each specific Wikidata page to see, is the dinner party mentioned? And then for this particular one, the output was a CSV. Partly, I was curious about how to make a CSV using Google Colab, but also just because it is a long but generally stagnant list. The only thing that's been changing is the dinner party being listed on more pages. Some pain points here. Attributes are not consistent across the pages. In some instances, it says part of the dinner party. In some instances, it says depicted by the dinner party. So it does require multiple searches, looking not only in under one attribute. Second, the name that's listed might differ. So the name on the dinner party heritage wall page, people go by a lot of names. Sometimes there's a middle name, sometimes there's a title. And when it differs from the Wikidata page, there was a little bit of difficulty there. And then finally, there can only be one person in a cell. For this particular project, that didn't really matter because there's only one person listed in each cell. But when I reused this code in order to look at an award, for example, if there's multiple people who won the award in 1 year, it can't go into the cell, pull out all 3 of the people who won the award and look at each of those people regularly. It sort of pops up an error message. But an advantage with this project is it's possible to reuse it in a lot of different ways, which wasn't as applicable in the previous project I discussed. Thank you.
Thank you, Rebecca. And next we have facilitating entity management with activity streams with Stephen Folsom, head of metadata design and operations, and Simeon Werner, associate university librarian at Cornell University. So you should both have screen sharing.
Hey, thank you, Huda. I am Simeon Warner, and I will hand it over to my co-presenter, Stephen, after a little while. If we could have the first slide, please.
Can you not see it?
Oh, sorry, the next slide.
Oh.
The one that isn't just the names. Oh. Thank you. Okay, so I was tempted to start this talk by talking about the complex processes we use to update MARC authorities, but I realize this is a lightning talk. So instead, I'll start in the linked data world, where at least different entities and authorities have identifiers that are separate from the labels we use to talk about them. And I'm going to start off by talking about some experience for the LD4P, Linked Data for Production project, and the entity lookup service, which has been used to provide entity lookups in association with the questioning authority editor that we already heard some discussions about. The goal of this work was to provide a standardized interface for lookups and autocompletions over a wide variety of authority sources that may themselves have different APIs, causing difficulties with integration. So this sort of separates the authority API compatibility problem from the problem of building a linked data editor, Sinopia, which can then treat the authorities in the same way. We ended up following 2 different technical approaches, one of which we call direct lookups, where we provide an on-the-fly translation between an individual authorities search and the standard API. This doesn't have any problems with understanding updates. However, we also created various cache lookups where data is loaded either out of band via some peculiar mechanism or through a download or something into a cache that was part of our system maintained by David Eichmann at the University of Iowa. And then we provide the standardized search interface over that. This is great in the sense that it provides us ability to control the uptime and the responsiveness, although there's a bunch of work to keep it up to date. And throughout this work, we ran into a number of different problems, some of which, different date formats, inconsistent search semantics, but repeatedly the idea of, if we've got a cache lookup, how do we understand the changes in the source data to maintain that cache in an efficient way? So that's Next slide, please. One of the two motivating use cases for this work. So the other one is this same problem that we have with marked data, but which will be replicated in a linked data world, which is how do we update labels in our data as authoritative sources change? So these two use cases are our motivating drivers for this work, maintaining local caches and updating labels. The fact that there is no widely accepted solution for doing this in a standard way leads to a proliferation of, I would say, problems, but I guess we put solutions in quotes here. You know, we can end up paying people to do it. We end up writing bespoke processes for every different authority. You know, we just ignore it and say it's too hard. We won't solve that. And we should be able to fix this. Next slide, please. So a bunch of us from the LD4 community got together to try and tackle this problem. You'll see the editors list for the current draft on the right, and there's been variously different levels of participation for different people over time. I'd like to highlight as we talk through this that Lynette Rail was the initial coordinator of this work and has since left academia, and Stephen Folsom, my co-presenter, has ably taken on the coordinating role. So we have good representation. We've had a regular process of meetings that are open. We have all our notes kept in open channels and also in GitHub for work on the spec. And if anyone cares to join the group, please do. Next slide, please. So before I hand over to Stephen, I'd just like to sort of touch on perhaps the resolution of the biggest topic we've talked about so far. And that relates to the life cycle of an entity and the complexity with which we model that. If we think about the management of authority data, we can imagine many complicated changes beyond the simple, say, a label change. We can imagine merges and splits and all of those things. But what we've ended up as a result of our discussion is the idea that we're going to treat entities individually with a rather straightforward model of creation, update, and deletion, where the handling of more complex relations is handled by links between entities and those updates. So we imagine a model where an entity is either created or becomes known to the community, first made public. There's some sequence of updates. Maybe it changes a label, maybe it changes a definition. Maybe there's an update which changes its definition because it's been split into two terms. So there'll perhaps be an update to one and a link to a new, or perhaps that split is modeled by the deletion of the original entity, the final step in the life cycle, and the creation of two new ones, which would again be linked. But anyway, at the end of the process, the last thing that can happen to an entity is that it is deleted or discouraged from use, deprecated. Next slide, and over to you, Stephen.
Okay, and so to start thinking about a specification or an API, we looked at this problem space and we decided that we would focus on activity streams. Activity streams is a W3C spec, and it's widely used and supports linked data. There's prior art for this specific problem of trying to communicate changes within a data set. Getty Vocabularies has an implementation and Library of Congress has an implementation. They differ in ways that suggest that this work could be useful, so that if there are meaningful changes, we can expose them, and where there are not meaningful changes, maybe converge in practice. And really, one of the things that I find useful about activity streams is there seems to be sufficient semantics for these minimal requirements that Simeon just mentioned. The model provides, a central part of the model is these idea of activities or actions that are taken on an entity and the ability to say when they happened and the type of action or activity that occurred on that entity. As with all things linked data, there's the potential for extensions. We're trying very hard to use activity streams, the activity streams vocabulary to the extent possible, and but we're open to this idea of extending new types and where we feel like the semantics needs to be a little bit more explicit, and I'll touch on that in a second. And also, there's so as Simeon said, we're going to try to focus on updates generally, but we understand that there may be value added in the stream saying exactly what things changed for a given entity description. So there's some built-in organizational structures. There's this idea of an ordered collection. Essentially, that's an entry point into the stream, and then the collections are broken up into ordered collection pages. So here you see that we have page 2, it's previous page 1, the next page is 3, and then, sorry. Let me go back. My cursor's jumpy. And so we have 2 activities here, a create and a delete. So our current status as to types, we're adopting a model where creation and add are used for new entities to pay attention to, update for changes to entities. We've extended with this idea of deprecation for entities that still exist but are discouraged from use. And then finally, activity streams delete for things that no longer dereference. Ideally, we wouldn't delete URIs, the whole cool URIs orthodoxy, but this at least gives a paper trail for entities that used to exist for consumers. As I was saying before, we may want to say what exactly changed for a given entity type, and we sort of settled on this optional idea of using RDF patch. And essentially what you can do is, for example, here we have the entity milk, and it's been updated, and the A down there in the content says that a new label or a new statement was added to that description, capitalizing the M, and we have a deletion of the previous statement where milk is lowercase. You can imagine a more useful example, but that's at least approachable. So in order to conclude this round of work, in case it's not clear, we're still actively working on it. One of the last substantive areas that we want to work on is consistent date property usage. There's a number of ways that activity streams makes available, or they provide a number of date properties, and depending on your interpretation of their definitions, you might decide on one or the other. But we'd like to sort of narrow that down so that consuming applications don't have to look for a bunch of different properties. We have, as with all all APIs, we need to do some editing for clarity and consistency, remove artifacts of previous ideas. As Simeon said, we've been at this for a while, and there's old thinking still in some of our recommendations. Clean up the examples, and then finally, we want to produce a first draft and invite feedback. And given that this is a first draft, we suspect that there will be further work on it and improvements, so we want to gather issues for future work. Ideally, we would also come up with some proof of concept consumer tooling. Here's where you can watch the work progress and get in touch with us for questions.
All right. Thank you, Simeon and Stephen. Next, we have testing cataloging workflows with Sinopia and Marva with Kaylin Blunt, metadata librarian at Pan Libraries. Over to you, Kaylin.
Hi, thanks for that introduction. I'm Kaylin Blunt, and today I'm going to talk about how we're testing cataloging workflows with Sinopia and Marva at Penn. At Penn, we have a number of linked data initiatives, of which this project is just one. The scope of this project is to test original cataloging using 2 linked data editors, Sinopia, the editor created as a product of the LD4P grant, and Marva, the Library of Congress's linked data editor, which was demoed earlier today. Our testing involves creating descriptions in both editors and comparing the different cataloging experiences in each system, as well as exporting MARC that the editors have converted from BibFrame into our ILS's testing environment called Alma Sandbox. And one of our goals here was to test creating linked data descriptions while also getting an output that we can use in our ILS now, which uses MARC, or in future possible hybrid MARC linked data environment that could proceed a full transition to linked data. And for our testing, we're cataloging books from our general collections cataloging backlog. And these are mostly non-English language monographs in Latin scripts, so Spanish or German, for example. And we're planning to test non-Latin scripts at a later phase of testing. Our testing so far has been in 2 stages. So the first stage was cataloging a resource 2 times, once in OCLC Connection, which you can see on the left, and once in Sinopia, which is the editor we began testing first. After creating the work and instance descriptions in Sinopia, we had Sinopia convert the BibFrame into MARC, which is what you can see on the right. And the purpose of this was to be able to look at both MARC records and compare them side by side. And for the next stage, we tested exporting MARC generated from both editors into our ILS testing environment, which is Alma Sandbox. So on the screen, this is what the bib record looks like after it's been converted from BibFrame to MARC in Sinopia and then exported into Alma Sandbox. And next, I'll have a brief overview of what each editor looks like and how the experiences cataloging in them are slightly different. So this is a screenshot of Sinopia's stage environment showing a PCC profile or template for monographs, which Penn has been using for this testing. In the upper right-hand corner, there are 2 important features that we use during the testing. The first is that MARC button, which leads to some drop-down options. So after creating your work and instance BibFrame descriptions, you can use this button to request conversion from BibFrame to MARC, view the generated MARC, or download the description a couple of different ways. And then next to that is the export to catalog button, and that's been configured to send that generated MARC to our ILS testing environment. And what you see on the screen here is what you see when you log onto Penn's instance of Marva. So this is an editor created by the Library of Congress, and we've downloaded and made a local copy of that so that we can use it and have it send MARC to our Alma Sandbox. And one exciting feature that we've been testing is our instance of Marva has been configured to pull in data from already created MARC records and have that data pre-populate the BibFrame fields. So right now we can pull data from MARC records in a few different places. And the one that we've tested the most is pulling data from WorldCat records via their OCLC number. This is particularly helpful because many of the items that we're cataloging for this testing are non-English language books that don't have English copy in OCLC, but might have non-English copy. So we can pull the data from the non-English record, if it has one, and use that as a basis for creating a new English record. And this is what Marva looks like when you're working on a description. We'll have seen a more in-depth view of this from the demo earlier. But it's similar to Sinopia in that you're still filling out what looks like a form, but there are some differences which I'll go into on the next slide. So the way that you create data is slightly different in each system. In Sinopia, there are customizable templates or profiles, and you can use ones already created, like we use the ones created by the PCC. But you can also use others or create your own. And in Marva, there's one template that you can use for each format type, so you can't really customize or create your own. The layouts are also different. So in Sinopia, there's a multi-tab layout. You open up one tab for a work description, another for an instance, and another for an item. You can go back and forth between them. And in Marva, the main view that we were looking at was one big page with the work description at the top, followed by the instance description below it after you scroll down. And some other differences, as I mentioned before, our instance of Marva has been configured to import records from other sources, and this capability doesn't currently exist in Sinopia. And in Sinopia, you can look up and use terms from multiple different vocabularies, so LCSH or FAST or others. And in Marva, you really can only look up Library of Congress vocabularies. And then in Sinopia, if you can't find the term via lookup, you can add your own label and URI if there is one. And in Marva, you can't really do this. And there are also differences in the MARC mappings, which mean that the MARC exported from Sinopia will look a little different in our ILS than the MARC exported from Marva. So now to take a look at what some of those generated MARC records look like in our testing environment. This is an example of a MARC record generated by Sinopia and exported into Alma Sandbox. And I'll briefly go over just some of the things we can learn from this record. Something you'll notice in the record right away, and also that you'll notice in the one from Marva that I show after this, is that we have the URIs generated in the subfield zeros to enhance the records. There's also some information in the 754 and 884 fields at the bottom of the record that reference the conversion used and create some linkages back to the BibFrame description. And then you'll also notice that there's no ISBD punctuation because BibFrame doesn't need that. And then just some other things to touch on to provide some examples of what you might notice after a MARC conversion. So here you'll notice that a 264 copyright date and a 520 summary note aren't displaying, even though they are in the Sinopia description. Also, many notes that you might expect to see in specific 5XX notes fields are in generic 500 notes fields, and the subjects are not in cataloger order. And now here's an example of a MARC record generated by Marva and exported into Alma Sandbox. So this is a description of the same resource described in the previous slide, this time converted to MARC by Marva instead of Sinopia. And again, here I'd like to touch on a few examples of what you might notice after MARC conversion that are different from the output of the Sinopia conversion. So here you can see that the 264 copyright date and 520 summary note are displaying, but the illustrative content doesn't map to the 300, but rather the 340. And the 655 genre form terms display twice with different indicators, even though they're only input once in Marva. So again, these are just some examples of the differences between the outputs. There are also differences in more differences in the conversions, like, for example, in the generated fixed fields and others. And now just some takeaways. So some successes from the testing so far are the ability to view sets of records in our ILS and see what these MARC records look like, what tweaks might be necessary before we move to production. We've been able to show these records to our BibFrame working group at Penn, generate some discussion, talk about best practices and next steps. It's also been really helpful to compare the cataloging experiences in both editors side by side, as well as to do some troubleshooting, submit tickets or figure out workarounds. And then some of the challenges from the project. I think the editors provide us with some pretty good MARC records, but even so, the MARC mappings aren't perfect. So these records do still need to be edited a bit further after export. The editors are also evolving as we test, which presents its own challenges. And then there's the big question of how do we incorporate this testing into our production workflows. And then some future plans. We've been primarily testing monographs. So in future testing phases, we'd like to test other formats as well as non-Latin scripts. We're also starting to think about how we'll use or modify this process to overlay brief records that we already have in our system, like order records. We're also continuing to have discussions within the library about BibFrame best practices. In the future, we'd like to take a look at how the converted MARC displays in our catalog and get a sense of what our users might see. And then the big next step, as I mentioned previously, is moving these testing workflows to production and hopefully moving forward to some sort of hybrid environment with MARC and RDF. Thanks for listening. If you have any questions, you can ask after this, I suppose, or on Slack. You can also email me at my email here. Thank you.
All right, thank you, Kaylin. We have just a few minutes for questions. There might be some people who are having trouble seeing the Zoom screen, but I did the Slack and also for that one person I linked to Kaylin's Sketch page, which also has the PDF in case people are having issues. I could see them fine. So, okay. So, Christine, do you want to spend the next few minutes relaying questions from Slack?
Yes, there are a number of questions that have sort of been answered already or have engendered a great deal of discussion. I'll start with the most recent one, which was for Kaylin, which is Callie is asking how much editing takes place after export. Is the editing equal between Sinopia and Marva, or are there different editing considerations for each, and how different are they?
I'd say there are different editing considerations for each just because of how the conversion tools create slightly different mark records. I'd say it's not like onerous, and between the two, it's probably a bit similar. There are just different things that you need to edit. So for example, you might need to add back in that copyright date that I noted was missing earlier, or something else, depending on which editor it was converted from.
Thanks, that's great. Jumping backwards to one of the first questions that was asked and was answered with some with some nice citations and further reading. Miklos Hube asks, can BibFrame and RDA/RDF live peacefully together? Do they need to? Does anybody want to address that, or is that a minefield?
I know I was hoping I would not be called on to address this question. I mean, it's obvious. I have no answer for this question. And as I kind of intimated in my talk, we have an interest in creating a new RDA RDF data set. We did create one back in 2019 and 2020. Our application profiles at that point included a lot of properties which have now been deprecated because of the 3R project. But that was a great learning experience for us, and we were actually able to run an RDA RDF to BibFrame conversion and feed that back into Sinopia. And I'm thinking of this as a learning experience and something to share with the community, as I mentioned, as we evaluate data models. As I said in Slack, I'd love to participate in and invite more discussion on this very large topic.
Thank you for attempting to answer. Moving on, Dorothea Salo asks about the Women in Red list and what to do if you don't actually want to show up on it. There's a long discussion thread here that has some solutions, but I guess I wanted to kick it back to the presenter. So if somebody, is there some way of noping out of being a woman in red?
I mean, that is one of the risks of bots. You can't figure out, there's not that personal interaction there. Someone recommended taking female out of the Wikidata, which seems like that would be probably the easiest way to do it. But yeah, like I said, the problem with bots is there is not that personal interface.
Got it. Thank you. And then I think the last question, actually, there's a couple more questions. There was a question to the activity streams folks about whether this could be applied to things beyond linked data cataloging applications. I don't see any intrinsic reason it couldn't be made to work in a MARC environment. Does Stephen or Simeon want to summarize their comments from that thread?
I'll give a start. There's no reason it couldn't work. Well, with the right conditions, yes, MARC could be accommodated. So if the identifier for the linked data entity matched a MARC authority, and assuming the consuming application could access the MARC authority, if that was their preference, yes, they could pull that down and cache it. There are implementations that do this. I won't name them because of the marketplace around MARC authorities, but it is possible to do this, to access MARC authorities as they change using activity streams.
Great. And Alexandra Provo is asking, do you have suggestions about where/how to learn more about activity streams?
I can put a link in the chat to the primer. That's a good place to start.
Great, thank you. And I don't see any other questions. I see Adam Schiff's comment but I think this is rhetorical. If we have RDA as our standard, why are we not cataloging an RDA/RDF? That's the basis of what UW is thinking. Does anybody want to jump back to that, or should we? Actually, it's 3 o'clock. We should wrap up. Unless somebody has a pithy 10-second thing to say about that. Okay.
It's a great summation. Thank you, Adam. That's it.
All right. I'm going to hand facilitation back to Huda.
And I will find the unmute button. Success. Okay. Thank you very much to all the lightning talks. I think it might sound a little corny, but I think we hope to see all of these sort of, further fleshed out, and maybe we could have full-length presentations or working sessions next year. There's been some great work that you've all shared with us, so we really appreciate that you submitted that and were able to present. And please continue the discussion on Slack. There's already been some pretty intense questions and answers there. So it's great to see everyone engaged there. Okay, thank you very much. Christine, did we have any last, Callie, or have any last words before we end? I don't know. That seems like a no. So I'm good to call it. Callie, go ahead.
No, just 2 seconds. We may have a recorded keynote up later tomorrow, hopefully, and if not, maybe later in the week. We did touch base with Sarah and hope to have that up soon. Thank you, everyone, for a great day. Today was fantastic.
Thanks so much.
Thanks, everyone. We'll see you all tomorrow.